This is the second presentation on gravitation, and we're going to look at Newton's law of gravitation. And Newton's law of gravitation states that any two masses will exert an attractive force on each other, and that force will be proportional to the mass of each object and inversely proportional to the square of the distance between the objects. Mathematically, we can therefore say that force is proportional to the product of the masses. That's the mass of the first object multiplied by the mass of the second object, and if we were to draw a graph of force on one axis against the product of the masses on the second axis, we get a straight line. We can also say that force is inversely proportional to the square of the distance between the objects. So mathematically, this is how it's written. Force is proportional to 1 over r squared. This is known as an inverse square law. So it's from Newton's law of gravitation that we get our first equation. And that is that the gravitational force F is equal to g, where g is the gravitational constant, multiplied by the mass of the first object, multiplied by the mass of the second object, and all divided by r squared, where r is the distance from the centre of one object to the centre of the second object. Now you need to be aware of a common mistake in that working out the distances between objects, you need to measure from the centre of one to the centre of the other. So if you're wanting to work out r for this satellite, which is orbiting the Earth, then you need to add the height of the satellite above the Earth to the radius of the Earth. That's how you'll get the total radius of the orbit. We now move on to a question about a giant pizza. An unlikely scenario, but nevertheless it's in orbit between two planets and it experiences no resultant force. So what does this mean? Well, it means the forces on the pizza must be balanced. It means that the attractive force F1 on the pizza, which is exerted by planet 1, must be equal and opposite to the attractive force F2 on the pizza, which is caused by planet 2. And you'll often get questions like this in exams, and it just involves balancing both sides of an equation. Now let's think about a man who has a mass m1 and he's standing on a planet and the mass of the planet is m2. What would happen to the force F on the man if we double the radius of the planet? Well, if r suddenly goes to 2r, that's doubling the radius, then the force, if we look at that equation and we take 2r and we put it in place of r in that equation, then 2r all squared is 4r squared. So we can work out that the force will be a quarter of the original force if we double the radius of the planet. What would happen to the force if we half the mass of the planet? Well, from the equation you should be able to see that if we half the mass of the planet, then we're going to half the gravitational force. A favourite question on exam papers involves the density of a planet. Density is mass divided by volume, and you should know that volume is proportional to the radius cubed. So we can say in that case that density is proportional to mass divided by the radius cubed. And I'd like you to think about the following examples. If the density stays the same and the radius doubles, what must happen to the mass? What about the second scenario? If the density doubles and the radius also doubles, what must happen to the mass? And finally, if the mass doubles and the radius doubles, what must happen to the density? And when you've thought about those scenarios and got your answers, that's the end of this part of gravitation.
Created using Powtoon.